Hello, everyone. My name is Sriram. I'm part of the product management team for Aruba Central. I also have here with me Jose.
Jose Tellado. I'm actually HP Fellow and Chief Technologist of the Wi-Fi Analytics team.
So we'll be co-presenting this session today. Really honored to be presenting in front of you. Really happy to announce that, the last 1 year have been really exciting. We've seen tremendous growth and adoption with our Aruba Central Cloud Platform. We've had thousands of new customers that have adopted the Aruba Cloud Platform over the last 1 year. And at the same time, we've also had some of our existing customers that run our on-prem or they've never had a management adopt our Aruba Central. So we have about 20,000 plus customers on the Aruba Cloud Platform. And that's across multiple verticals, including K through 12, distributed enterprise, retail, hospitality, financial. So we have customers across all the verticals on Aruba Cloud. Today, we have about 500,000 devices sending data telemetry streams back to the cloud. We've processed data from about 12 million client devices, and that approximately translates to 1.5 billion records every day, and 9 terabytes of data every month that we process on the cloud, right? And that's a lot of data. That's a lot of data that we process on the cloud. And as you all know, data is one of the most critical components of any machine learning engine or machine learning algorithm, right? And we've seen that over the last year, as we started processing more data, it has definitely increased the accuracy of our machine learning algorithm. Okay, so that's just one. But as you know, it's not just about the amount of data. It's also about the quality and the diversity of data, right? So earlier I mentioned that we have customers from various verticals. So that definitely adds to the diversity of data that we have on Central, and that feeds into our machine learning engine. The second is we actually process close to 100 plus features on the platform today. And features are nothing but properties or characteristics that define a specific phenomenon. So things like client SNR records, TX bytes, RX bytes, 2.4 gig channel utilization, 5 gig channel utilization. These are various features, right? So we have about 100 plus features that we process, and that's expanding, right? So as we learn, we are expanding on the telemetry stats that are being sent from the infrastructure devices, and that increases the number of features that is processed on the cloud. And that is two things. One is we've seen that the more number of features we have not just helps increase the accuracy of our engine, but it also, and sometimes, helped us provide or generate some new insights. Okay, we'll talk about that when Jose provides more information about this. The last aspect is we are also in a position where we are collecting data from 3 different endpoints in the network, starting from access point, the switch, and the gateway, right? With our SD brand solution, we manage the full stack, which provides us a unique opportunity to look at data from all the 3 devices. And now what we could really do is when we have a client issue, we can correlate that to any part of the network and provide a unified view for our customers. Okay. So how is all of this coming together on the Central platform, right? So again, really excited to announce that with the latest release of Central that actually went out a couple of weeks ago, we have made the AI Insight engine completely integrated into the Aruba Central platform, right? So the workflows are fully integrated. What we've really done is we have taken the AI Insight engine, all the learnings and the models that we built over the last 3 years, and we're running those models on the Central data set, right? So we have now a new set of data coming from Central. We're applying these models, and what that means for our Central customers is now they can take the benefit of the AI engine platform, AI engine, and we also have integrated these workflows completely into the central dashboard, right? So we'll show a quick demo of that later in the presentation, but it's now available to all our central customers today. Now that we've seen how it's coming together, what kind of data we process, I'll let Jose walk through, what are some of the insights that you're seeing with the data that we're processing on the cloud platform.
Okay, so this wouldn't be a data science or machine learning like talk if you didn't actually project 1 billion rows with 100 features into 2 dimensions in color. So this is what this is, actually. So we get 500,000 APs, 10 million stations, and we want to featureize how the station capabilities, the AP capabilities, how the APs and stations are engaging, whether it's bytes or applications or SNRs, and how the APs are engaging, how their channels are distributed, how the path loss between a 2.4 and 5 gigahertz radio is, and then try to project APs in a 2-dimensional plane. So each dot here is one AP. Basically, you got a 100-dimensional space projected in 2 just so we could see it. And then the color are different vertical tenant site sizes. So as you can see in this plot, this reddish area, which I covered the tenant just for privacy reasons, is actually a...
Oh, I'll cover it.
Something, sorry. Oh, wow. It's actually a cell phone retail store center. These are actually a fast food, sit-down restaurant area. These are K through 12. Ooh, wow. These are hotels. So what this is telling you is you get 100-dimensional vector, and you get Wi-Fi environmental features. And you could actually separate the APs in a 2-dimensional space using those features. Of course, we're not going to process 2 dimensions, but we could see it like this. The benefit of this is then you could overlay lots more APs in here. And in this case, there's 20,000 APs in this plot. But as Sri said earlier, we're currently processing 500,000 APs. If I showed 500,000 APs here, it'll just be blue. And basically what we could say is that the APs in this area are small distributed retail environments. These are hotel-like areas. Actually, I forgot to say this is a senior living center, which seems to be halfway between hotels and K through 12. But the benefit of this is we could do peer comparison recommendations. So say, for example, in this area, there's some configuration that actually makes this perform 20% better than the peers. We could change all the other blue APs so they're as good as the red ones. So this is actually what we've done in the campus environments, and now we could apply to the distributed environment. We were actually a little concerned because in the previous generations, and I was here last year, we talked mostly about campus deployments where you have many APs together. You have thousands of APs in a similar 1 by 1 mile radius. In some of these deployments, you have one AP in one store, and there's no other AP from Aruba anywhere within a mile, or half of that. But now we could actually get learnings from one AP in one site across thousands of sites and actually figure out how to optimize that one AP, even though there's only one AP by itself. And one AP doesn't have a lot of data. You cannot do data science on one AP. But if you have thousands of APs that are close to each other in this environmental dimension, you could actually give very good config recommendations. So this is actually data from insights running from our West A cluster. There's actually 150,000 APs in here. And I just want to give you some statistical data. Again, there's 500,000 insights in here. And we want to show in a 2-dimensional plot. So to just give some idea of what's happening, this is the site size. So site size 1 means you have only one AP in that site. And actually, all these are customers that have only one AP per site. Here is customers that have 70, 80 APs per site. So basically, this is like small hotels, K through 12, fast food chains, retail things. The bubble size is how big the tenant is. So this has 6,000 APs. I know that doesn't say it. This is also 6,000 APs. And I only chose tenants that have at least 100 APs. The y-axis is how many insights they're getting currently from Central. Sri's going to walk you through one tenant, which is actually our Chennai office, and only has 10 APs. These have 6,000 sites with one AP each, and these have hundreds of sites with 40 AP each. And what this is telling you is that we are able to find at least, by the way, this is the number of insights per AP. So basically on the average, an AP in Central, West A, is getting an average of about 3 insights right now in their dashboard. So this is analytics on their dashboards. We cannot show you a dashboard from them. But basically, they're getting insights right now. Of course, a lot of times you have 6,000 APs and they have a common insight, so you do one change and you fix 6,000 things. But in any case, in this dimension, you want to be lower. You want to have less issues, because most of these insights are actually anomalies. So you want to minimize your anomalies. You want to be going down in this y-axis. And the color-coded is a fraction of APs that have issues. You can see some of these green tenants have very few issues, but some of these have a lot of issues. So like I mentioned earlier, based on how similar APs are in a high-dimensional space, and based on which APs are doing better than others, you could actually give recommendations to make people have less things reporting in the dashboard automatically. Our estimate, based mostly on campus side, is we could easily improve the number of issues they have by 30% within the next year.
All right, okay. So thanks, Jose. So what we're going to do is, like Jose mentioned, we will pick one live site that is running, and we'll show you how the insight is integrated into the central platform, right? So just give me a second while I bring this up. All right, okay. So this is the central cloud platform, right? Just want to let you know that we made a lot of changes over the last couple of months on Central, and one of them is obviously bringing insights as part of the core workflow into Central. And what you see here is one of the sites that is at Sydney. It has about 10 APs, and I've picked one particular access point which actually shows the number of insight that the access point has, right? So you can see that in the access point detail page, we have now introduced the insight tab. So this insight tab information that you see here is being fed from the AI insight engine that's running all the models on the central data set, right? So I see an insight called high airtime utilization on the 2.4 gig channel. And then, obviously, when I expand on the information, you can see the airtime utilization for last 1 week and the average airtime utilization over 1 day. And what's really important is to note that we actually baseline this. OK, there you go. You see a black line. That's the baseline on which we compare the airtime utilization. So what Jose mentioned earlier is we actually characterize and put our customers into buckets with similar characteristics, right? So this AP is compared to peer networks of very similar behavior, right? So we calculate a baseline for peer networks and compute how the AP metric is as compared to very similar peer networks, right? So in this case, you can see that the average utilization in this peer network was about close to 20%, but this particular AP experienced high utilization. Yes, sir.
How are you defining the peer networks?
Okay, so do you want to?
Yes. Yeah. So peer networks is based on their Wi-Fi environments, not on manual labeling. We do not want to go through 500,000 APs looking through their labels and figure out if it's a K through 12 or if it's a retail store. So the peer means they have similar Wi-Fi environments. Device mix, device behavior, device applications, AP density, AP to AP path loss, SNRs, all the things that are going to that 100-dimensional thing that makes two APs look similar.
Yep, thanks. And that's what you saw on the plot, right? So the plot was not separating out customers by verticals, but it was more separating out customers by these different features, plotting on them, and then the plot itself showed that they actually have different distinct characteristics.
The color label was added later,
yeah,
just so to show you that it was clusters.
Yeah.
So there wasn't one thing that you were saying. We're measuring SNR for all of our.
No, there's like
whole
100 things in there between
like a
device, bytes, applications, APs.
Okay. Yep. So all the features. Yep.
Of course, we operate in the higher dimensional space, but to show the fact that it's finding interesting structure, I showed a two-dimensional color plot.
Gotcha. Yeah. All right. So the baseline is calculated on the peer network, and then the severity of the insight, which is the color, whether it's red, yellow, or green, shows how much it deviates from the baseline, right? And obviously this shows is quite bad. The next thing we do is we augment this insight information with more information for the users to understand what's happening with the network, right? So for example, we tell you the potential root cause of why we see high channel utilization. We also show the channel utilization by channel. So here it says what is the typical channel utilization, which is on the right. That's the channel utilization during typical part of the day, and what is the worst, right? And then we have hour of the day. So this plots the channel utilization over time, right? So what this tells you is if there are certain trends or if there's a certain period in the day where channel utilization is high, this chart will clearly show that. And then clients, right? So the client view tells, again, the list of clients, all the clients that were connected to this AP when the channel utilization was high, along with their average SNR, right? So you can see that there are clients with low SNR that probably contributed to high channel utilization. And then finally we have TX power. This tells you what percentage of time the AP operated on different transmit power. Again, so all these rollups, what we call rollups, are calculated based on the features that we have built, and this helps. Intention is to help users and get to the root cause of the problem much faster. Okay, and so let me get back to the slide. So again, just want to iterate that with the latest release of Central, we have made the AI Insight as core part of the Central workflow. So if you're a user that's trying to troubleshoot an AP issue or a client issue, we will augment that information with with information from the AI Insight engine, right? So that's a quick demo. Okay, so, all right, thank you. All right, okay, so so far we saw how we gather data from the network perspective, right? So what about the client perspective? So we have the user experience insight. So user experience insight, it's a sensor, dedicated sensor that's deployed in an environment, can be wall mounted, placed on a desktop. It simulates client traffic. You can define network test, not just network test, but application test like Box, Dropbox, Slack, Zoom, Skype, and the number of applications is just continuing to expand. You can schedule to run them at certain period of time, and when we see anomalies, we send the data back to the cloud. Now, ever since the acquisition of Cape, we have seen the number of sensors, 10x more sensors being deployed in a customer premise, which means that we are running almost 115 million automated tests every day, right? And all this data is being fed back into our cloud platform, right? So that's, again, a lot of data that we're getting from a client perspective. So that kind of completes the picture for us, where the Insight provides us the data from the network perspective, and the sensors provide data from the client perspective. I just would like to conclude by saying that if the last 1 year was exciting for us, I think there are a lot of exciting things that we're working on for the next 1 year. There's going to be a lot of features and exciting features that will be launching as part of our continuous upgrades on the Central platform. So let me just leave it at there, and thank you, everyone.
Thank you.
Yeah.
So, your last presentation used the word insight probably every 10th word. So you use the word insight. Is it a verb, a noun, a product, a piece of data, a device?
Okay. So insight is, so when I showed the demo, right, we talked about insight is information that says there is something wrong with the network, or there's an anomaly on the network, right? So for example, it's a piece of information, yes.
Is it also a product?
So the insight is a feature that we have on Central. It's our core engine, AML engine, that takes the data, processes data, and provides those insights, right?
You just used the word and you said insight provides insight.
So
insight.
Exactly. So the feature is called AI Insights. That's what we call it, and the information that it bubbles is called insights. So that's how we've
just a little.
Yeah, sure. Yeah. So does it clarify, or yeah?
As mud.
Yep.
Yeah. Do you want?
So you have the user experience testing and the network testing. Does it tell you whether, when it's saying in that example, channel utilization was high, Does it actually tell you whether the user experience is bad at that site at that time?
Okay, so
So is it, because it said here's a remediation, but as an administrator, do I really want to remediate it if the user experience isn't bad?
sure. Okay, so what we're doing is, I think the way our data model works is, this is new data set that we're getting from Central, right? So obviously, I think we presented last year, the AI engine has been running for the last 3 years. We've been building models over the last 3 years, and the way our engine works is, whenever we get new data set, we build a certain level of confidence. For example, all the plots that Jose showed, those all is based on the data that we build in the backend. So before we launch it into the product, we want to build a certain level of confidence, because we want to run the model, train it, see the level of confidence we build, and then make it available as part of the product. So as what you see here is the opportunity for us, now that we have data coming not just from the network side, but also from the user experience side, where we have the opportunity now to make that connection between what happened on the network versus what happened on the client.
So currently no, but future yes.
Yes, absolutely, yeah. Because it's just saying the potential of what we could do. In the back end, yes, we can build that model, right? We could show charts that actually getting this data and build the models, but not in the central product yet, because
each product is generating models independently right now, but the data is being stored for the last few years, so we could do joint models very easily. But yes, right now they're independent. Hopefully they don't contradict each other. So the good thing is that we're storing the data, so as we get more intelligent in our modeling, we could just go back and make the models very accurate very quickly. So it's not like in the next month we're going to develop new models and we have to wait a year for them to get accurate. We have a year worth of data, so they'll get accurate very quickly. Right.
Sorry, you might have mentioned it, but how long do you store the data?
So we don't delete it. The model-based data, we don't delete it. The individual user, yes. Yes, so all the RF performance metrics in device analytics, we don't delete those models. So every time we get a new device, it makes the model better, but we don't age out devices that we haven't seen lately.
Is there any way we can configure that, or?
So in Central, you could configure it. In the campus side, we don't currently have a configurable knob. But one thing is a user connecting to an IP for a certain time. That's something that's a little private. But knowing that a MAC address has a certain capabilities, saying that this OUI, this range is capable of 11AC wave 2. That's not private. The fact that your device did wave 2 3 years ago, if we we just keep the OUI in the range, we don't know it's your device. We just know that these MAC addresses from here to here have 2 antennas. These have 1 antenna. These do multi-user MIMO. These don't. That's for this modeling. Because when we try to figure out what's the performance of a link, we need to know the AP capability, which we know because we make the APs. The device capability, we learn it. So we can delete device capabilities from a year ago, 2 years ago, because then we may forget what 11Ns look like, and then we cannot predict how they do next year. And there's still a lot of 11Ns out there. At least 20% of devices are still 11N. We can delete that knowledge. But we don't keep the individual person, just the MAC address range in the modeling.
Something